Yes. Okay, today we will discuss residue integration KTU problem. So, so the first problem is evaluate this problem. Evaluate the integral of c tan z divided by z square minus 1 dz counterclockwise around c mod z equal to 3 by 2 by using residue theorem. And second question is this. Okay. So before going to the first question, let us discuss what is residue theorem. So let us recall residue theorem. So if f of z be analytic inside a simple closed path C and on C. So that means if you have a simple closed path C counterclockwise C and the given function f of z must be analytic inside and on C. That means we have to the function must be analytic inside and on C. And then except except for finitely many singular points. That means z1, z2, etc. zk inside C. So f of z is analytic inside and on C except for finitely many points z0, sorry z1, z2, etc. zk. So there are finitely many singular points inside C. Then integral of f of z taken counterclockwise around C equal to 2 pi times sum of residues of f of z at z equal to at z1, z2, etc. zk. So if f of z is analytic inside on and on C except finitely many points, that means there are finitely many singular points, then integral over C f of z dz is equal to 2 pi I times sum of residues. So this is a residue theorem. This is very simple compared to other methods. So the thing is you have to know how to find out residue of function. So let us do first problem solution and evaluate integral of c tan z divided by z square minus 1 dz counterclockwise around c mod z equal to 3 by 2 by using residue theorem. So, for solution we have given, first we will draw the curve. So what is our curve? C is mod z equal to 3 by. Now mod z equal to 3 by 2. So what is that? This is a circle with center 0 and radius 3 by 2. So here 3 by 2 minus 3 by 2. This is our C. Now we want to check what are the singularities inside and on C. So tell me, so given f of z is tan z divided by z square minus 1. So tell me what are the singular points. F of z is analytic everywhere except at okay. Tell me what is tan z. Tan z is tan z in the what is tan z?
Sine by cosine.
Sin z by cos z, right? Sin z by cos z. So when is cos z becomes 0? Cos z will be 0 at ഏതൊക്കെ പോയിന്റ്സിലാണ് plus or minus
pi by 2.
5 by 2 plus or minus 3 pi by 2, etc. Right? And what are other singular points of f of z? When become denominator 0, tan z divided by z square minus 1. What are other singular points?
1 minus
1 and minus 1 is equal to 1 minus 1. Okay. Now we have to check which of the singular points are inside C. Is pi by 2 is inside C? What is C? C is mod z equal to 3 by 2. So what is the value of pi by 2? Pi by 2 is by 2, right? 3 point, I think 3.14 something by 2. Is it greater than 3 by 2? Pi by 2. Is pi by 2 is
Yes, sir.
outside C? Yes. Pi
Outside.
by 2 is outside C, right? Minus pi by 2 is also outside C. And all other terms, 3 pi by 2, everything is outside C. So these all are outside C. And what about 1 and minus 1? Is it inside?
yes inside.
Yes. Yes. So 1 and minus 1 are only singular point inside C. Therefore, we can write f of z is equal to tan z divided by z square minus 1 is analytic everywhere except at z equal to 1 minus 1 on C. So we will consider the singular points inside C, only those singular points which is inside C. Okay, now what is residue theorem tells us? So what is by residue theorem? Residue theorem. Integral over C f of z dz is equal to what is residue 2 pi I into sum of residues, right? Sum of residues. So how many singular points are there? 1 and minus 1. So we want to find out residue at 1 and residue at minus 1. So that is equal to 2 pi I into residue of z equal to 1 f of z plus residue of z equal to minus 1. So now we will find a residue of f of z at z equal to 1. First we will find residue. So what is f of z here? F of z എന്താണ്? Tan z divided by z square minus 1. So yesterday we studied a formula, right? What is that formula? Let us recall yesterday's formula. I will go through yesterday. This formula. This is very easy. That means residue. This residue of f of z. If f of z is of the form p of z by q of z, then residue of p of z divided by q of z is equal to p of z naught divided by q dash of z naught. So this formula, this is very important. And when we can use this formula, if f of z is of the form p of z divided by q of z, and we want p of z not equal to 0, and q of z has a simple 0 at z naught. Simple 0 means, what you mean by simple 0? 0 of order 1. That is q of z naught must be equal to 0, but q dash of z naught not equal to 0. Then we say that. Let us move to the residue. Okay. So, so, so by formula, so you have to bifurcate this. If f of z is of the form p of z divided by q of z, where where what are the condition? P of z not equal to 0 and q of z naught must be equal to 0 and q dash of z naught not equal to 0. So the conditions are, we have p of z naught must be equal to 0, p of z naught must be equal to 0, q of z naught must be equal to 0. Sorry, p of z naught not equal to 0, q of z naught must be equal to 0, and q dash of z naught not equal to 0. So now let us check here. Here, what is this is of the form p of z divided by q of z, right? Where p of z is equal to tan z and q of z is equal to what z square minus 1. Now check about z equal to 1. Is p of 1, so here z naught, what is z naught? Z naught is equal to 1. So what is p of 1? Tan 1, which is not equal to 0. Any doubt? What is q of 1? 0. You put 1 here, 0. What is q dash of z? And the q dash of z,
2 sir.
q z, right? So q dash of 1 is 2. Now what is by formula? Residue at z equal to 1. Tan z divided by z square minus 1 must be equal to p of 1 divided by q dash of 1. So that is equal to tan 1 divided by q dash of 1 is 2. So we get first residue. Now you find out the second residue. Residue of f of z at z equal to minus 1. Our f of z is of the form tan z divided by z square minus 1. Now tell me what is residue z equal to minus 1 tan z divided by z square minus 1. Anybody?
Tan 1 by 2.
tan 1 by tan 1 by 2 then അല്ലേ എന്തുകൊണ്ടാ? Because we have here p of minus 1 is equal to tan of minus 1, so this must be equal to, right, p of minus 1 divided by q dash of minus 1. So this is minus 2. Tan minus 1 is minus tan 1 divided by minus 2. Minus and minus get cancelled. Tan 1 divided by. Therefore, by residue theorem, what will be integral? Integral over c tan z divided by z square minus 1 dz is equal to 2 pi I into sum of residues. And tell me what are the residues? 2 pi I into what are residue? Residue at z equal to 1 tan z divided by z square minus 1 plus residue at z equal to minus 1 tan z divided by z square minus. So എന്തൊക്കെയാണ് റെസിഡ്യൂ കിട്ടിയത്? First one, what is this residue?
Tan 1 by
Tan 1 by 2 plus tan 1 by 2. So this is equal to 2 pi I into tan 1. Okay, so this is the answer. So residue integration is very easy if you know how to find out residues. Okay, have you got it? Any doubt? Okay, now we will do this problem. Okay, ഇത് ഞാൻ പറയുന്ന ആൾക്കാര്